Hello everyone. Now in this video we are studying on the very interesting topic in operating system, and this topic is also very last chapter of operating system. So till now in the operating system we have covered some of very tedious topics which are completely theoretical, which you cannot see by your own eyes. We have covered topics like process scheduling, we have covered topics like memory management, we have covered introduction, deadlocks, and so many things that we have covered. Now in this video, because this is coming out to be in the very last of operating system, the last chapter of operating system. So I just wanted to give you some practical feeling about what we are going to study and what are the topics that we will be covering here. So this topic is actually about the secondary memory. So till now the topics that we have studied, they are from the main memory or according to the software that is operating system. Now this is about the secondary memory. And as you can see, I have already have a secondary memory here, which is the hard disk drive. So this hard disk drive is, I took it out from a laptop, but again some of your computers, some of you are having bigger drives as compared to this. This is a very small drive, very compact drive. As you can see, this is a 750 GB drive. So it's a very compact drive. Okay, so some of you might be having much bigger drives as comparative to this. So this is I feel this is there's some length is also written. Okay, so on your desktops generally we are having 3.5-inch drives, which are basically bigger than this big in size. So we are going to study how these drives are made up of. So what are the things, what are the elements in this drive which makes us, or which stores data, how we are going to store the data, how we are going to retrieve the data from the hard disk, and rather in the hard disk what are the different forms and different structures of the hard disk. Okay, so this is a internal diagram. So let me first do one thing, let me show it to you logically how these things are working, and then again I am going to come back to this diagram. Okay, now in this drive we have something called as a magnetic disk. So I think you must have seen CD drives and DVD drives with you, right? CD drives and DVD drives, they are actually once you write data on the CD and DVD drive, you cannot erase them, right? But in case of hard disk, you can erase them. It is because the hard disk is containing these kind of drives, but these kind of drives are actually magnetic in terms of hard disk. So we store data as a magnetic charge. So you can see these kind of drives are actually inside this hard disk. So because it's a very smaller hard disk, so it will be having very small disks like this. But when you have bigger hard disks which are of 3.5 inches or something, now on those disks we have these kind of magnetic drives, and all these drives are actually stacked over each other. Stacked over each other means, so there will be one drive like this, then we will be having one more drive under this, then we will be having one more drive under this, and we will be having different platters on this. So platters, I should say platters, or you can say surfaces. So as you can see, we are having an upper surface on this and we are having a lower surface on this. Again, a part of this we can have one more disk here. Again, in that disk also we can have an upper surface and we can have a lower surface. So this disk is actually inside a hard drive. As you can see, there is a video that I have included here in this video, where I am showing a working mechanics of the secondary memory, that is a hard disk drive. Now in this disk we have something called as tracks. So what are tracks? These round circles, these are actually tracks, and these tracks are actually divided around something called as sectors. Okay, now imagine it like this. This is your hard drive and this is one of your platter. Okay, so this way we are going to have more than one platters. Now in every platter there are two surfaces, there is an upper surface and there is a lower surface. Okay, so we have an upper surface and we have a lower surface, and to rotate these platters, as you can see, these platters are standing something called as spindle. So what happens is this spindle rotates, and because this spindle rotates, therefore the disk also rotates like this. Okay, so spindle makes them rotate. Now there are different speeds of the spindles. For example, you have 5400 RPM hard drives, which is that is 5400 rounds per minute. That means in every minute they are going to take 5400 rounds like this. We also have hard drives which are 7200 RPMs. We also have a hard drives that are approximately 9 to 10,000 RPM, and we also have some special drives these days which are also taking a speed of 15,000 to 20,000 20,000 rounds in a minute. Now if the speed of rotation is more, obviously the rate at which you are going to read the data from the hard drive, that is also going to increase. So generally it is better whenever you are going to purchase a hard drive or secondary memory, then it's better to look at the speed or RPM of that particular drive. For example, here the drive that I am having here, so here somewhere here they must have written what is the rounds per minute or what is the RPM of this hard drive. So in this hard drive is actually approximately, so this is rotating at a speed of 5400 RPM. So in most of the drives the speed is also written. Okay. Now coming back to this, so these drives are also having tracks, they are having these rotations are tracks, and in every track is divided into sectors. So there are many tracks, as you can see there are many tracks in a drive, in a platter, and every track is divided into various sectors. Okay, and the number of sectors in every track is going to be equal. So how does it, how do we do it? So you can see the most inside track here that is having more density. So what happens is in the hard disk, when you come to the most inside one track, I mean the inside track which is closest to the center, that track is having highest density of storage. So it stores more information because the number of sectors even in that inside track, that is going to be equal as compared to the number of sectors that is on the outer side of this drive. Now what happens is we have something called as read write head. Now as you must have seen the old gramophones or where we used to have something this kind of structure, that we used to have a structure where we used to put some plates here, and according to this, on this there's some instrument that you write on this, these plates used to rotate, and accordingly we used to produce some kind of sounds. Okay, so these are old Graham bells, I think they are called as Graham bells. So these Graham bells produce music. In the same way, in hard drive, to read the data from the disk, we used to put something called as a platter on this. So there's a something called as a read write head on this. So there's a read write head, but this read write head cannot touch the drive, because when this read write head will touch the drive, so because the drives rotate at so much fast pace, it rotates at so high speed that if this is going to touch it, so it is going to create scratches on the surfaces of this drive, and if it is going to create the scratches on the surface of this drive, so obviously your drive will get corrupted. So sometimes that is the reason why you are going to get bad sectors on your drive. Okay, why you are going to get bad sectors? Because these read write head, if sometimes by mistake if they touch it, it creates a problem. So generally they do not touch. So there is a gap between this drive and this this platter and this read write head, and this gap is actually an air gap. So because this drive is going to store information in terms of charge, because it is a magnetic disk, so it has to read that magnetic charge. Okay, got it? So this is how your drive is structured. Now our aim in this chapter is, number one is we are going to study about the surface of this drive. I mean, if let us say this in every sector, if I am going to say in every sector I am going to store this much bits or bytes of information, and I am going to tell how many tracks are there, and I am going to tell how many sectors in a particular track, then can you find the capacity of this drive? And secondly, we are also going to discuss about that if let us say we want to read the data from the drive. Obviously to read the data, what you have to do is to read the data you have to take this read write head on the particular sector. For example, you have to take this read write head on the particular track from where you have to read the data, and then you have to come to the desired sector on that track. So when this read write head comes to the desired track, then you have to come to the desired sector on that track, and there is some time that is utilized on the basis of that, and accordingly you have to measure that if you want to read some specific bytes of data, let us say you want to read some 3 MBs of data or 4 MBs of data, let us say you want to read some 1 GBs or TBs of data, then how much time will it take for this drive to transfer all the data from the disk? Okay, so this is the main things that we are going to study, and a part of this there are something called as disk scheduling algorithm. Disk scheduling algorithm means if this is the track, so if this is the platter and this is your read write head, then how you are going to create the movement of this this particular read write head so that you can minimize the number of movements so that you can read the data faster. So just like we have seen the process scheduling algorithm. So according to different kinds of process scheduling algorithm, we were getting different kind of features. For example, in shortest job first, we were getting maximum throughput, right? In longest job first, and we have the time quantum based algorithm, even we have the first come first serve algorithm. There were some kind of features. Some of those algorithms were having problem with starvation. Some of those algorithms were giving maximum throughput, some of those algorithms were giving minimum throughput. There were some problems with that, right? So in the same way, so when you are going to schedule this read write head over the disk, I mean which sector it has to read or which track it has to read, on which sequence it has to process the request of the user, the amount at which you are going to or you can say the rate at which you are going to read the data from the disk is going to change. So obviously for that we are going to study something called as disk scheduling algorithms. So disk scheduling algorithm is also a part of this particular chapter. So initially what we will do is we will start with the secondary storage, some basic problems according to secondary storage which is about given a disk, this is the amount of data that you can store, and according to the amount of data, what is the capacity of disk. So we are going to look at some very easy questions and then we will look at some disk scheduling questions. I hope this was helpful for you. So let me do one thing, let me write down 1 or 2 questions and accordingly we will start. Okay.